Students, let us learn the topic quadrilaterals from Standard 9th Maths Part 2. In this topic, we are going to learn some types of quadrilaterals, their properties, and some examples based on them. So let us start with the basic definition of a quadrilateral. Suppose there are four non-collinear points given in a plane. Let them be A, B, C, D. If we join each point of out of these four with other two, we will get segment AB, segment BC, segment CD, and segment AD. So by this we have got a compact figure which is called as a quadrilateral. So here A, B, C, D are four vertices of a quadrilateral, while and AB, BC, CD, and AD are the sides of a quadrilateral. Now suppose if we join the opposite vertices of a quadrilateral ABCD, that is if we join A and C, we get a segment AC which is called as a diagonal. Similarly, there is another pair of opposite vertices B and D. If we join them, we get BD which is another diagonal of quadrilateral. So for any quadrilateral has four vertices, four sides, four angles and two diagonals. Now let us learn some basic concepts of a quadrilateral. For this, consider quadrilateral A, B, C, D. Now let us have pair of adjacent sides. So if we consider segment AB and segment BC, as we can see, one vertex is common over here, that is vertex B. That's why these two sides, that is AB and BC, are adjacent sides, or it is the first pair of adjacent side. There is another pair. The second pair of adjacent sides is segment BC and segment CD. So again, as we can see, BC and CD has one vertex in common, that's C. That's why BC and CD are adjacent sides. Similarly, segment CD and segment AD are also adjacent sides, and segment AD and segment AB are adjacent sides of quadrilateral ABCD. Let us have the next concept, that is pair of opposite sides. Now for this, if we consider segment AB and segment CD, as we can see, segment AB and segment CD does not have any vertex in common. So such pair is called as pair of opposite sides. So AB and CD is the first pair of opposite sides. Similarly, AD and BC, it is another pair of opposite sides. Now the next concept we are going to learn is a pair of opposite angles. So angle A and angle C, or if we expand this as angle BAD and angle BCD, these are exactly opposite to each other. That's why it is the pair of opposite angles. There is another pair of opposite angles, that is angle B and angle D. In this topic, we are going to learn some types of quadrilateral. The first type of quadrilateral, that is very basic, is a parallelogram. Then we are going to learn rectangle, then a rhombus, square, and trapezium. So in this topic, we are going to learn these types of quadrilaterals, their properties. We are going to prove those properties, and we are going to solve some examples based on that. So let us start with a parallelogram. Suppose if we have a quadrilateral PQRS. So here PQ and SR is the pair of opposite sides, and PS and QR, it is another pair of opposite sides. Now if we extend PQ, or if we draw a line passing through side PQ and a line passing through side SR, as we can see, they do not intersect each other at all. That's why these two lines are parallel. Similarly, if we draw a line through side QR and a line through side PS, we can also see that these two lines are also do not intersect each other. So by this we can define that if the pair of opposite sides of a quadrilateral is parallel to each other, then the quadrilateral is called as a parallelogram. So in this case, quadrilateral PQRS is a parallelogram, as its opposite sides are parallel to each other. That is, PQ is parallel to SR and PS is parallel to QR. Now let's see properties of parallelogram. The first property is adjacent angles of a parallelogram are supplementary. So as we can see, PQ is parallel to SR. That's why angle P and angle S are interior angles. And in earlier topic, we have studied that if two lines are parallel, then the interior angles are supplementary. That's why angle P and angle S are supplementary. The second property is opposite sides of a parallelogram are congruent. So PQ is congruent to SR and PS is congruent to QR. The next property is opposite angles of a parallelogram are congruent. That is, angle P is congruent to angle R, and another pair of opposite angles is angle Q and angle S. So these are also congruent. Next property is diagonals of a parallelogram bisect each other. Now let us prove these properties. The first theorem is opposite sides and opposite angles of a parallelogram are congruent. To prove this, we need a diagram. So let us have this diagram. So ABCD is a parallelogram which is given. And as it is a parallelogram, opposite sides must be parallel. That is, AB must be parallel to CD and AD must be parallel to BC. That's given. Now we have to prove that the opposite sides and opposite angles of this quadrilateral are congruent. That is, AD is congruent to BC, that we are going to prove. And another pair of opposite sides is BC and AB. So to prove that these two sides are also congruent. Now we have to also prove opposite angles of this quadrilateral are also congruent. That is, angle ADC and angle CBA. These two angles are opposite angles. So we have to prove that these two are equal. Similarly, angle DAB and angle DCB are also congruent, that we are going to prove. Now to prove this, we need one construction, that is, we have to draw a diagonal AC. So that is the construction. Now we will start the proof. Now, as it is a parallelogram, BC is parallel to AB, and as we have drawn a diagonal AC, we can treat it as a transversal. So if it is so, then angle DCA and angle BAC, these two angles are alternate angles. That means they must be congruent, because we have studied that if there are two lines parallel, then the alternate angles formed are congruent. Similarly, there is another pair of alternate angles, that is angle DAC and angle BCA. So these are also alternate angles, so they must be also congruent. We'll call these as equation number 1 and 2, and obviously we have to give reasons for them, that is alternate angles. Now consider triangle ADC and triangle CBA. So as we can see in the diagram, triangle ADC and triangle CBA, we are trying to show these two triangles are congruent, but we have to consider that the correspondence must be in this way, that is triangle ADC and triangle CBA. The first component, we have angle DAC is congruent to angle BCA, as we have proved this in equation number 2. Similarly, angle DCA is congruent to angle BAC. This is because from 1 in 1 we have proved that. And there is one common side, that is side AC is common for both of these two triangles. So it must be congruent. So segment AC is congruent to segment CA. So as we can see here, for these two triangles, there are two angles and side between them are congruent. That's why these two triangles are congruent by ASA test. That is, triangle ADC is congruent to triangle CBA by ASA test. That is angle side angle test. Now, as we know, if two triangles are congruent, their corresponding sides are also congruent. So if we consider the side AD, its corresponding side is CB. So we can write side AD is congruent to side CB, as these two are corresponding sides of congruent triangles. Similarly, side DC is congruent to side AB, which are again corresponding sides of similar triangles. So in this way, we have proved that two opposite sides of a parallelogram are congruent. Similarly, Angle ADC is congruent to angle CBA. As these two triangles are congruent, the corresponding angles are also congruent. So angle ADC, its corresponding angle is CBA. So these two angles are congruent. And the reason is corresponding angles of congruent triangles. In the same way, the second pair of opposite angles can be shown to be congruent. That is, angle DAB is congruent to angle BCD. And hence, we have proved here that the opposite sides and opposite angles of a parallelogram are congruent. Let us consider the next theorem. Diagonals of parallelogram bisect each other. So to prove this, again we must have a diagram. Let us consider quadrilateral PQRS, and it is given that it's a parallelogram. Now here the diagonals are PR and QS, and as we can see they are intersecting at point O. So that's given. We have to prove that these two diagonals intersect each other. That means diagonal PR makes two equal parts of diagonal QS, that is QO is congruent with OS. Similarly, diagonal SQ makes two equal parts of diagonal PR, that is PO is congruent with OR. So our proof is, we have to prove that segment PO is congruent to segment RO and segment SO is congruent to segment QO. So let us start to prove in triangle POS and triangle ROQ. So consider these two triangles POS and triangle ROQ. For this correspondence, we have angle OPS is congruent to angle ORQ, as OPS, this angle, and angle ORQ, as we know that it is a parallelogram and these two angles are alternate angles, that's why they are congruent. Similarly, side PS is congruent to side RQ because these two are opposite sides of a parallelogram, and we have just proved that opposite sides of a parallelogram are congruent. That's why we can write side PS is congruent to side RQ. There is another pair of alternate angles, that is angle PSO and angle RQO. So these two angles are again alternate angles, so they must be congruent. So as we can see, for these two triangles POS and triangle ROQ, we have proved that these two angles and there is a side between them. So these two triangles must be congruent by ASA test, that is angle side angle test. So if these two triangles are congruent, the corresponding sides must be also congruent, that is segment PO is congruent to segment RO. There is another pair of corresponding sides, that is side SO is congruent to side QO, and for both of these the reason is corresponding sides of congruent triangles. So that is, we have to prove that PO is congruent to RO and SO is congruent to QO. So in this proof we have proved that diagonals of a parallelogram bisect each other. Now there are certain tests of parallelogram by which we can identify a given quadrilateral, whether the given quadrilateral is a parallelogram or not. So for that we have some tests. The first test is, if pair of opposite sides of a quadrilateral are congruent, then that quadrilateral is a parallelogram. Suppose there is a quadrilateral given of which the pair of opposite sides are congruent, then that quadrilateral must be parallelogram. To prove this theorem, we need a diagram. So let us consider quadrilateral PQRS, which is a quadrilateral. It is given that in quadrilateral PQRS, it's given that side PS is congruent to side QR, as these two are opposite sides of quadrilateral. There is another pair of opposite sides PQ and SR, which is also given to be congruent. So PQ is congruent with SR. So it's given. And from this we have to prove that the quadrilateral PQRS is a parallelogram. So for this we have to do one construction. We have to draw a diagonal PR. Now by doing the construction, we have got two triangles, that is triangle SPR and triangle QRP. For these two triangles, Side PS is congruent to side QR, which is given. Again, side SR is congruent to side SR is congruent to side QP, which is also given. And side PR is congruent to side RP, as this is a common side. So side PR is common side for both of these two triangles. That's why these two triangles are congruent by SSS test. So triangle SPR is congruent to triangle QRP. Now, if this is the case, then we know that the corresponding angles of congruent triangles are congruent. So if we consider angle PRS in diagram, if we can see angle PRS, this one, is congruent to angle RPQ. So, and the reason is corresponding angles of congruent triangles. As we can see, these two angles are alternate angles. So we have studied one test, that is the alternate angles test, that if there are two lines given and if there is a transversal and the alternate angles so formed are congruent, then these two lines must be parallel. So by alternate angles test, we can have that side PS is parallel to side QR, and the reason is alternate angles test for parallel lines. Similarly, we can show that another pair of opposite sides, that is PQ and SR, are also parallel by alternate angles test. So for this quadrilateral, both the pairs of opposite sides are parallel to each other. So by definition of parallelogram, we can conclude that quadrilateral PQRS is a parallelogram, and we have to prove that if pair of opposite sides of a quadrilateral are congruent, then that quadrilateral is a parallelogram. The next test of parallelogram is if both pairs of opposite angles of a quadrilateral are congruent, then it is a parallelogram. So to prove this, we need a diagram. So let us consider a diagram. In a diagram for quadrilateral EFGH, it is given that angle E is congruent to angle G. So it's given that both opposite angles are congruent and we have to fill in the blanks. So this is the first pair of opposite angles. The second pair of opposite angles is angle H and angle F. So here it is given that both the pairs of opposite angles of this quadrilateral are congruent. Now to prove, we have to prove then quadrilateral EFGH is a dot dot. So by this statement, we can fill this as we have to prove quadrilateral EFGH is a parallelogram. Now to start with the proof, let angle E is equal to angle G is equal to X, as these two angles are given to be congruent. Similarly, angle H is equal to angle F is equal to Y, as these are also given to be congruent. As we know the basic property of sum of all angles of a quadrilateral is 360 degree. So if we add measures of all of these four angles, we get angle E plus angle G plus angle H plus angle F is equal to 360. Now if we replace angle E and angle G by X and angle H and angle F by Y, so we have, and instead of angle E we can write X, instead of angle G we can write again X, and angle H and angle F, instead of that we can write Y. So X plus Y plus X plus Y, that is equal to 360 degree. So X plus X we will have 2X, and Y plus Y we will have 2Y, that is 2X plus 2Y is equal to 360. If we divide by 2, we'll get X plus Y is equal to 180 degree. So as we can see, angle X is a substitution for angle G, and Y is a substitution for angle H. So in diagram we can see angle G and angle H. So their sum is 180 degree, as we have proved here. And in this quadrilateral, these two are interior angles, and we have studied the interior angles test, that if there are two lines given and if there is a transversal, and by that if we have two interior angles supplementary, then those two lines are parallel. So by interior angles test, we have these two. So by interior angles test, we have these two lines are parallel. Similarly, we can prove the second pair of opposite sides is also parallel. And by the definition of a parallelogram, we can prove that the given quadrilateral EFGH is a parallelogram. So we have to prove. Now let us consider the next test of a parallelogram. The quadrilateral is a parallelogram if pair of its opposite sides is parallel and congruent. So for that, let us consider a quadrilateral ABCD. It is any quadrilateral given, and in that quadrilateral it is given that segment CB is congruent to segment DA. CB is congruent to segment DA, which is the pair of opposite sides. And it is also given that segment CB is parallel to segment DA. Again, the same pair of opposite sides is given to be parallel. And from this, we have to prove that the quadrilateral ABCD is a parallelogram. So for this, we have to construct diagonal BD. So by constructing diagonal BD, we have two triangles, triangle CBD and triangle ADB, which we can show that these two triangles are congruent by SAS test. So as these two triangles are congruent, their corresponding angles must be congruent. So angle CDB is congruent to angle ABD. So these two angles are congruent by corresponding angles of congruent triangles. So if we consider these two angles are alternate angles, and by this alternate angles test, we can show that side CD is parallel to side AB. Similarly, we can prove that the another pair of opposite sides, that is CB and DA, are also parallel. That's why by definition of parallelogram, we can have that both the pairs of opposite sides of this quadrilateral given are parallel to each other. That's why the given quadrilateral is a parallelogram. So now we can recall the test of parallelogram. The first test of parallelogram is a quadrilateral is a parallelogram if its pairs of opposite angles are congruent. Second test is a quadrilateral is a parallelogram if its pairs of opposite sides are congruent. Next test is a quadrilateral is a parallelogram if its diagonals bisect each other. And the next test of parallelogram is a quadrilateral is a parallelogram if a pair of its opposite sides is parallel and congruent. So these theorems that we have just proved are called as tests of parallelogram, that is by which we can identify whether the given quadrilateral is a parallelogram or not. So let us consider the next type of a quadrilateral, that is the rectangle. So let us have this diagram. So as we can see in a quadrilateral ABCD, each angle, that is angle A, angle B, angle C and angle D, is of measure 90 degree, that is it is a right angle. So such type of quadrilateral is called as a rectangle. Define this as if opposite sides of a quadrilateral are congruent and each angle of a quadrilateral is right angle, then the quadrilateral is a rectangle. Now let us consider properties of a rectangle. The first property is opposite sides of a rectangle are congruent. That means the side AB and side CD, these are opposite sides of a rectangle, and side AD and side BC, it is another pair of opposite sides, so they must be congruent. The second property is each angle of a rectangle is a right angle, as we can see in the diagram. Next property is diagonals of a rectangle are congruent. So in this diagram, AC and BD are the two diagonals of quadrilateral ABCD, that is the rectangle ABCD. So they must be congruent, that is AC is congruent to BD. Consider the next type of a quadrilateral, that is a square. In this diagram, quadrilateral PQRS is a square. Let us Let us learn the properties of a square. The first property is all the sides and angles of a square are congruent. In spite of rectangle, here all the sides and all the angles are congruent. In the case of rectangle, only all angles are congruent, that is each angle of a rectangle is of measure 90 degree. Here also for the square, each angle of a square is of measure 90 degree and all the sides are congruent. As we can see in the diagram, quadrilateral PQSR, PQQS, and RS are the four sides of quadrilateral which are congruent. The next property is diagonals of a square are congruent. So in this diagram, PS and QR are two diagonals which are congruent. The next property is diagonals of a square are perpendicular to each other. That means in this diagram, PS and QR intersect at a point inside the square. At that point, a 90-degree is formed. A right angle is formed. So this is the next property of a square. That is, diagonals of a square are perpendicular to each other. Let us consider the next type of quadrilateral, that is the rhombus. Consider quadrilateral ABDC, which is a rhombus, and in that diagonals of a rhombus are perpendicular bisectors of each other. That means if we draw diagonal AD and diagonal BC, they intersect at a point where a right angle is formed and they bisect each other. The second property is diagonals of a rhombus bisect the pair of opposite angles. So angle A and angle D, these are opposite angles. Diagonal AD bisect these two angles. In the same way, diagonal BC bisect angle B and angle C.